In the last 20 years, natural hazards on our planet cause between $180 and $200 billion of damage per year, according to the UN Office for Disaster Risk Reduction, with many of them having geological causes. As geoscientists, we want to improve our understanding of these natural processes, but one barrier to this is a lack of consistent measurements over time, as lots of geohazards occur in difficult-to-access places or cover really large areas. Earth observation is a method of monitoring physical processes and changes of the Earth using satellites in space, and so is a great way of filling this gap in measurements by providing more regular observations over the Earth's landmass. Something that I use very often in my job is a technique known as INSAR, which stands for Interferometric Synthetic Aperture Radar, and we use this to measure how quickly the land is moving. This movement can be due to several geological processes such as landslides, volcanic swelling, subsidence, coastal erosion and earthquakes, to just name a few. Other than INSAR, we can also monitor plant health, soil moisture, thermal emissions and other important environmental variables using satellites. Clearly, the satellite-based Earth observation market has been exponentially growing and in the UK is expected to increase by nearly $1 billion by 2030. Additionally, the Copernicus programme, run by the European Commission, generates 25 terabytes of data per day, and this is equivalent to the storage of nearly 49 iPhone 17s. So this is an awful lot of data that we have to process and manage. Analysing this amount of data and extracting any meaningful trends from it by hand would be nearly impossible, and so we need to utilise machine learning, statistical and artificial intelligence tools to help us with this. This is why BGS has developed several such tools, and we will show you how one of these tools works, which we call the Automated Regression-Based Time Series Classification, or ARCTIC for short, to help us automatically analyse satellite data and specifically to identify trends and patterns and changes in ground motion over time. In the next video, part 2, will provide a more comprehensive overview of INSAR, and then part 3 is designed to help you learn how to use this BGS coding tool to analyse your own INSAR data direct from a BGS data scientist.